Before we start in on actually converting, we're going to talk a little bit about the purpose of percents. Percents are useful for making comparisons between quantities when the whole is not the same. For example, 8 correct on a test seems like it would be better than 4 correct on a test, but it depends on how many questions were on each test. So if we had 8 questions correct, but it was out of 20 questions, that would be 40% correct on the test. And if we had 4 questions correct, but that was out of 5 questions, that would be 80% correct. And 80% correct is better than 40% correct. So using percents is an efficient way to make comparisons when the whole or the one differs. When the whole or the one differs. So now we're going to jump in here to Student Math Journal, pages 147 and 148. Mathematically, a comparison with decimals is equivalent to a comparison with percents, but typically in our daily lives we use percents. And that is because with percents, the denominator is always 100. With decimals, the denominator can be 100, it can be 10, it could be 1,000, it could be a lot of different things. But with percents, it's always 100. In addition to multiplying by 100, decimals can be changed to percents in 2 other ways. So one way to do that is to take a decimal and to round it to the nearest hundredth. So if we had 0.25748, and we wanted to turn that into percent, we just round it to the nearest hundredth. 5 is in the hundredths place. 7 makes the 5 round up. So that would round to 26 hundredths, which would be the same as 26%. That's a rounding. Another strategy is to truncate the decimals. So if we had the exact same one, 25748, to truncate the decimals, you just kind of separate those two and you look at this number right here and we get 25 hundredths, which that then would go to 25%. So they're both close, but it's just a little bit different way of doing it. So now we're going to look at page 147 here. Excuse me. And we're going to look at the sample problem right here. Tennille used her calculator to rename the following fraction as a decimal and as a percent. So the fraction was 14/23. And to turn it into a decimal, she did 14 divided by 23 equals, and this is what she got for her answer. Then, as we talked about before, you could multiply that by 100. So you take 14 divided by 23 equals, and then do times 100, which would give you this answer here, 60.869, etc. Tennille needed to work with only a whole percent. So we're going to round it to the nearest whole, or the nearest one. So she rounded this 60.8. She looked at the tenths place here to round to the ones. 8 makes the 0 round up to 1, so it would be 61%. So I'd like for you to hit pause, and if I can get this to go right, I would like for you to go ahead and do problems, or fill out the rest of the chart using the strategy from above. Now on the 2, 3, and 4, there's some different things you have to do. They give you the percent and then an amount. In this case, this is the total amount. In this case, problem 2, this is how much money they had. This is how much it cost. You need to figure out how much they had to start with. And for this one, it's similar to this. You have how many questions there were. You need to figure out how many the total were. So this is total. This is the part. This is the part. In order to do this, you're going to look at the percent and the number. So for percent, you need to start by turning it into a decimal. So I want you to hit pause and turn each one of these into a decimal. Now for the decimal, 80% is the same as 8/10. Or you could even do 80/100. 50% is the same as 5/10 or 50/100. Doesn't matter. 75% is going to be the same as 75/100. Now, for this, we're starting with 20, and we're going to get a smaller answer. Here we're starting with 15. We're going to get a bigger answer. Here we're starting with 15 again, and we're going to get a bigger answer. In our thinking, typically to get a smaller answer, we divide or subtract. But with this, our number is smaller than 1. So if our number is smaller than 1, we have to multiply. In this problem, our number is smaller than 1. To get a bigger answer, we actually have to divide. And the same thing here. To get a bigger answer, we have to divide. Now I'm going to do a couple sample example problems, and then you can pause and get to work on 2, 3, and 4. So let's say that there is a test and there were 50 questions on the test, and whoever was taking the test received a 75% on the test. So we're going to get a smaller, our answer is going to be smaller since it's by a smaller number, smaller than 1, 75/100. We're going to take 50 and we're going to multiply it times 75/100. So I'll bring up my calculator. 50 times 50 times 75/100 equals 37.5. So 75% of 50 is 37.5. Then down here, let's say that we're going to go with 40%, which is a decimal, would be 4/10 or 40/100. Doesn't matter which one you choose. And we're going to say that he spent $30 on a hat. We want to find out what the total amount of money he started with was. He spent 40% of his money, which was $30. So we're going to get a bigger answer. Since we're dealing with a number smaller than 1, we're going to divide. And we're going to do 30 divided by 4/10. Bring up my calculator. 30 divided by 4/10 equals 75. So we started with $75. 40% of 75 is 30. And a way that we could check ourselves is we could take 30 divided by 75. that equals 4/10, which is our 40%. So go ahead and work through those problems, and then once you finish them, check them over with your partner